Hi, I'm Ken from Scotland, and this is my week 1 assignment for the course Introduction to Music Production on Coursera.org. I'm going to talk in this lesson about the units that we use to measure air pressure and how they can be turned into a more useful unit called the decibel. So to start off, let's imagine a patch 1 square metre at the surface of the Earth. And imagine the air column that supports going right up to the top of the atmosphere about 100 kilometres above. Now that's 100,000 metres. That's a lot of air in that column, and it weighs a considerable amount, roughly 10 tonnes. It's equivalent of 2 elephants sitting on this patch. That creates a lot of pressure. Now, we don't measure that pressure in terms of elephants. We use a unit called Pascal. And at the surface of the Earth, the average atmospheric pressure is 101,325 pascals. If we have a quick look at a weather map, here pressure is measured in millibars, but if we change the units and add a couple of zeros to these low pressures and a couple of zeros to this high pressure, you're looking at pascals. And the number that I mentioned, 101,325, being the average atmospheric pressure. Low pressure is called low because these numbers are less than 101,325, and this high pressure is called high because this number is greater than these. It's nice to know that we have experience of these numbers. So let's now look at how sound waves are generated in the atmosphere. Here's a representation of air molecules, and at the centre of this there's a vibrating object like a tuning fork or a guitar string that's just been plucked. And the vibrating object compresses air molecules next to it, and they travel out in a wave. The air molecules are compacted and rarefied in a periodic pattern, and this causes changes in the air pressure, which the ear then detects. Follow one of the red dots. It only travels a fixed distance. If there's more energy in these waves, it will travel a larger distance, and this will be detected by the ear as a greater air pressure change. That's what the amplitude of a sound wave is. Basically the distance that that wee red dot travels. Greater the amplitude, greater the distance that red dot travels, the greater the air pressure change that the ear will detect. And we perceive that change as loudness. So just how sensitive are our ears to the pressure changes caused by a sound wave? Turns out they are extremely sensitive. Sensitivity goes from 20 millionths of a pascal all the way up to 20 pascals. Now the scale here is in micropascals, which is millionths of a pascal. So 20 micropascals all the way up to 20 million micropascals. And it's a scale of numbers that's not easy to work with. We need a mathematical formula that converts these numbers into a more workable scale, a logarithmic scale called decibel. And there is a mathematical formula that does that, and at the heart of that is the idea of a logarithm. So we'll now have a look at what a logarithm is. 100 can be written as 10 times 10, 10 squared. The log to the base 10 of 100 is 2. 1,000 can be written as 10 cubed, 10 times 10 times 10. The log of 1,000 is 3, and so on. So the log scale can be built up in this way. And it goes from a rather strange scale on a ruler to one that's very familiar. So this is a logarithmic scale. Following the pattern down would get 10 to the power 0 being 1. So that's all that logs are. It really tells you the number of tens to multiply together to get powers of 10. So the actual formula is this. And in it, you'll see this pressure reference level, which is, in this case, 20 micropascals. So in here, we would use 20 micropascals, millionths of a pascal. And all pressure levels that we're measuring are measured relative to that base reference level, which is the threshold of hearing. So for instance, a sound pressure level change of 200 micropascals, that's 10 times this threshold level, compared to the base level of 20 micropascals, that's 10 times. This fraction becomes a value of 10. And the log of 10 is 1, as we found out previously. 20 times 1 gives us the value of 20. A sound pressure level of 2000 compared to this 20, that's 100 times. If we put 200 in 2000 in here compared to the 20, we get an answer of 100 for this fraction. The log of 100 we found out was 2. 20 times 2 gives us that 40. And this decibel scale is built up in that way. So that's the end of the lesson. I hope you found it interesting, and I hope you've learnt something about the units we use to measure pressure and how these are changed into a more useful scale, which is in this case the decibel sound pressure level. Thank you.